All right, so before we were taking graphs that were given to us and analyzing what was happening on those graphs. Now we're going to use the equation and what we know about the analysis we've done in order to create our own graphs. So the first thing that we're going to focus in on is the impact of the degree on the end behavior of graphs. Now what I mean by end behavior is this. If we had a sketch of a graph and it looks something like this or something like this, okay, the end behavior is what's happening at the ends. So in this case, it's going up at one end, down at the other. In this case, it's going up at both ends. That is based on the type of degree that we have. So if we have an even degree, it's going to do something different than if we have an odd degree. And remember, the degree is based on the highest exponent. So if my highest exponent is 2, my degree is 2. If my high exponent were 20, my degree would be 20. So if we look back at the graphs that we had just analyzed and look only at the even ones, okay, so here my even one, they're both going up at the end. These are both going down at the end. Another even one would be 4. These are both going up, both going up, both going down. So when I look at my even ones, the end behavior is that they both head in the same direction. So even degree, both ends of graph point the same direction. In other words, both go up or both go down. So if I were looking at this graph, I know this one is an even degree because they were both pointing the same direction. They were both going up. Now, if we look at the odd ones that we've done, so next part is the odd degrees. Let's see what happens with those. So if I'm looking at a degree of 1, one end's going down, the other one's up. One end's down, one end's up. One end's up, the other one's down. Does that still happen with a cubic? So third degree, up. One end's down, the other end's up. One end's down, the other end's up. One end's up, the other one's down. So when we look at these, we should realize that the odd degree, the ends of the graph are going to point in different directions. So the ends of the graph point opposite directions. One end up and one end down. Now the question is, how do I know in an even degree if they're both going to go up or if they're both going to go down? And obviously this one's an odd because they were heading in both directions. So now the question is, how do I know whether the end's going to go up or go down at each side? How do I know if they're both up or if they're both down? Well, that is based on the lead coefficient. Okay, so when we talk about a lead coefficient, the lead coefficient is the coefficient on the highest exponent. Or, in other words, the very first coefficient that you see. Now, when we talk about these, the big deal with the lead coefficient will be, is it positive or is it negative? That will determine what's happening in each one. So, for example, if we have an even degree, and we have a positive lead coefficient, then what would you think? Since it's even, either they're both up or both down. So do you think positive is up or positive is down? I always think of positive as up, which is really what happens. So positive lead coefficient means both ends point up. On the other hand, if it's an even degree and the lead coefficient is negative, then that tells me negative is like going down, so both ends will be down. So negative, both ends will go down in an even one. Positive, both ends will go up. Now, because with an odd degree, when we talk about odd degrees go in both directions, so that one takes a little bit more thought. So odd degree. If you have a positive lead coefficient, then the left end is up, or the left end is down, sorry. Left end down and right up. I really like to think of this as being kind of like slope. So a positive slope would go in this direction, right? It'd start with the left end down and the right end up. So that's what happens with an odd degree. It's almost like slope, okay? Like slope. If I want my slope to be positive, the left end should be down, the right end should be up. On the other hand, if we have a negative lead coefficient, then basically we want that to be like a negative slope, right? So if I think about a negative slope, it starts high and moves down, so the left end would be up and the right end would be down. Just like a negative slope. So the positive is like a positive slope and the negative is like a negative slope. So positive is like a positive slope. It goes down on the left, up on the right. Negative is like a negative slope, up on the left, down on the right. So when I look at this graph, I should know, based on its look, whether it's an even or an odd equation based on the end behavior. So since these are going in two different directions, that tells me that this is an odd degree, because an even degree would head in the same direction. And when I look at this, it says, is the lead coefficient of the equation positive or negative? So when I look at this, I think, okay, it's starting high and it's ending down. So it's kind of like this. So would this be a positive slope or a negative slope as I move across? Well, that would be a negative slope, so so I would have a negative lead coefficient. All right. Now we're going to use that information to create the graph. So here, first thing I realize is, well, instead of worrying about end behavior right now, we're going to talk about the behavior at the x-intercepts and sketching them, sketching an approximate graph based on this. So when we talk about the x-intercepts, right, the x-intercepts happen when y is 0. So basically I can set this, saying this equals 0 equals negative x plus 1 squared, x minus 3, right? And then we can set each piece equal to 0, telling me that x would equal 3 here, x would equal negative 1 here. And remember that this would have a multiplicity of 2 because my exponent is 2. So my x-intercept is negative 1 comma 0, and this one has a multiplicity of 2. And that multiplicity, remember, tells me, does it bounce or does it cross? And then the other one is 3 comma 0, and that one only has a multiplicity of 1. And that's my 3 solutions. So when I look at this, remember the multiplicity of 2, when we had an even multiplicity, it didn't cross the x-axis, instead it turned around. So if it's an even multiplicity, it will do what we call as bouncing. If it's an odd multiplicity, then it's going to cross the x-axis at that point. Whereas this one, which bounces, makes a U shape. So at negative 1, I should get a U shape happening. At positive 1, or at positive 3, it should cross. And now I'm going to look at my end behavior. 3 solutions means degree of 3, which means the ends are going to go different. Ends different. One's going to go in one direction, the other goes in the other. My lead coefficient here is negative, which means it's going to start up and move down. Right? Just like a negative slope would do. So when I look at this, I'm going to start up here. At this point, I am going to cross. So since it was a negative, we start from the top. We do not cross at -1, we bounce. So I'm going to come down. I'm going to bounce back up. Not sure how much, and then go back down again. So making sure my lead coefficient is negative, so this is like a negative slope. Degree is 3, so they're heading in different directions. I bounced at 2 and I crossed at 1. Now obviously this isn't the most accurate graph, because for all I know this could go all the way up to the top and come back down, or it could be smaller. We don't really know, but this just gives you a general view of what this graph should do. And I want you to try too on your own once we get to the end, okay, to try it and check it for yourself. All right. Example 3. Now this asks you to do this without a calculator. So they're asking you to find the x-intercept and describe the behavior. So when I look at this, it's 3, so we're going to go to grouping. Right? My GCF in the first group would be x squared, so we get x plus 2. Remember, since the first term is negative, my GCF would be -4, not just +4, so then x plus 2. So my two factors are x squared minus 4. X plus 2 equals 0. I can factor this again to be x plus 2, x minus 2, because they're both perfect squares having their differences. So that means I have x equals 2. I'm sorry, x equals -2, x equals 2, and x equals -2 as a solution. So now I know I have an x-intercept at x is -2, y is 0. The multiplicity is 2. Which means that it will bounce. My other x-intercept is at 2, 0. The multiplicity here is just 1, and since it's an odd multiplicity, that means it should cross the x-axis. Okay, you're going to try number 4 on your own at the end. And then the last thing we're going to do is we're going to actually take out our graphing calculators and use them to identify the x-intercepts, the local maximums, and the local minimums. So we're going to go ahead, turn it on, go to our y equals, clear it out, so we have x to the 5th minus 5x to the 3rd plus 4x minus 2. We're going to go ahead and graph that. Now the instructions are up here to remind you of how to find local mins, maximums, and zeros. So I'm just going to step through it, right? So I have 1, 2, 3 x-intercepts that I need to find. So we're going to go second calc. We're finding the 0. The 0 will help us find the x-intercepts, right? So I'm going to go to the left of that first one, which is right here. So I'm going to go to the left of it, which would be on this side. Now I need to go to the right of it. So now I'm to the right of that point. Press enter a third time. And so they tell me that happens at -1.89. So I'm just going to say -1.9, 0. And it crosses, so I know that has a multiplicity of 1, so that answer only happens once. Then I need to do that again for all the other ones, so 0. So this is the point I'm trying to find. Now I'm to the left of it, go over, and I'm to the right of it. Press enter. So that's -1.28, 1.289. So I'm going to say -1.29, 0. And that has a multiplicity of 1 because it crosses at that point. Again, we're going to do that for the third one. So this is my third x-intercept. So I'm going to go to the left of it, go to the right of it. And that one happens at 2.07, 0. And in this case, that crosses it, so that means that answer only happens once. So I know from this there's going to be 2 imaginary solutions. We know there's going to be 2 imaginary solutions. Now they didn't ask us about that, but just a reminder, because there has to be 5 solutions total. Now it's looking for local maximums and local minimums. So remember, the maximum is going to be the highest point, right? So if I look here, I have a highest point here in this general area. Then it goes back down and comes back up, so I have another local maximum here. So these are local maximums because they're not the highest in total, but they're the highest in this general area. So we're going to do the same sort of thing. We're going to calculate, but now instead of a 0, we're going to calculate the maximum. So I need to go over. And since I think this is like the maximum point, I need to go to the left of it. I need to go to the right of it, press enter. So now it's finding this point right here, which is negative 1.6, comma 1.6. Then I need to find this local max again. So we'll do that again, go down to maximum. So I think this is like the highest point, so I'm going to go to the left of it a few clicks, go back up to where I think the highest point is, go to the right of it a few clicks, press enter, and this is 0.54, comma, negative 0.58. And those are my only points where the graph goes up and turns around, so that's one local max, two local maxes, and that's it. Now I need to do the same thing with the minimums, so I need to find the lowest from those. So we're going to go back to the calculate, but now we're calculating a minimum. So right here, it's going up, 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 down, and it turns around. So this is a local minimum. So I'm going to scroll over to where I think that is. That looks like about the minimum. So I'm going to go a few to the left, scroll back over to where I think the minimum is, and go a few to the right, and press enter. And that one was negative 0.54, comma, negative 3.4. And then this one's a maximum, but then we come back down here to a minimum. So we're going to calculate the minimum again. I think the minimum's here, so I'm going to go to the left a few, go back to the minimum, go to the right a few, press enter again, and it was 1.6, comma, negative 5.6. All right, so then you need to try 6 on your own.